signs problem where there are two possible triangles. This graph depicts the path of the boat as it left the port, north 25 degrees east. So it's heading out this way and it overturns. It knows that it's 14 miles from this harbor here, which is 32 miles north of the port. So this red dotted circle is a circle centered at 0.32 with a radius of 14, and you can see that it hits the path of the boat in two different places. Now, one of those paths will take you to the point C here, and I've drawn in this radius, which is really the third side of this triangle. Now, by the way, how do you know that there are two possible triangles without actually drawing the circle? If you drop an altitude from that vertex to the opposite side and call this H, then it's true that the sine of 25 will equal H over 32. So H would equal 32 times the sine of 25, which I believe that's like 13 point something. So the fact is this third side of the triangle is greater than the altitude. That means there's going to be two possible triangles, where one where we draw this radius and another one where we draw this radius, which I'll go over on the next page. So the way it is right now, using the law of sines in this blue triangle, the sine of 25, that's this angle, is to its opposite side, 14, as the sine of C is to its opposite side, which is 32. And to solve for angle C, well, you can see the steps right here. I took the inverse sine of 32 sine of 25 divided by 14, which gives me approximately 75 degrees. That means that, let's see if I can get that erased there. I can't. That means that this angle right here is 75, 85, 90, about 180 minus 180 degrees. Okay, so to get from the harbor to the boat at point C, one way to do it is to say, well, what's the bearing? South, 80 degrees east. That's this guy right here. Now you could also say north 100 degrees, because this angle right here is 10 degrees. So I drew this little dotted line for the horizontal. So 90 plus 10 would be 100, but north 100 degrees east is not one of the choices. Okay, so that's one of the bearings. Now, if we go to board 2 and I draw in the radius to this instance of point C, I still use the law of sines and still get on a calculator that C is approximately 75 degrees. But what you have to know is that there is an obtuse angle that also has the same sign, which is the supplement. If you think of the unit circle, well, I won't do the unit circle here. I'll just say, here's a 75 degree reference angle. The sine of that angle will be this y value over the hypotenuse, and there's another angle over here in the second quadrant that also has the same sign, y over the hypotenuse, and that angle is 180 take away 75, or 105. That's this angle right here. Okay, so if I put a 105 in for angle C, 105 plus 25 is 130. That leaves 50 degrees for this angle. How do I get from the harbor to C? I'm south 50 degrees east. I think if we go back to board 1, south 50 degrees east. So there's 2 possible routes to the boat, but only because we don't know which position the boat is located at. There's 2 possible triangles. Okay, hope that helped.